Hello everyone, my name is Sayukta Mohan Raut, a third year MBBS student in Tashkent Medical Academy. So currently we are planning to start a series of subjects MedChem and MedBio. Actually it is just a help for the freshers who are coming. Now I am starting with MedChem and MedBio. In upcoming weeks we will start a series for other subjects also. Currently, sixth week is going on. So let's see what's the topic for sixth week in medchem. So the topic is basics of electrochemistry, electrical conductivity, conductometry, electrode process, potentiometry. In which we are gonna study electrical conductivity, resistance, specific and molar conductivity, electrical conductivity of tissues and biological fluids of the body, applications of electrochemistry in medicine, and later basics of conductometry, titration, emergence of potentials, electrode, redox membrane, and diffusion potentials. So let's begin. Okay, so first of all we will go for the definition, that is study of the relationship between chemical reactions and the electrical energy. It is just between electrical energy and the chemical reactions. First, what is electrical conductivity and resistance? Electrical conductivity is the ability of the solution to conduct electrical current depending on the presence of ions. So I want to tell you that if a solution has more number of ions, then it will be more charge carriers and the greater will be conductivity. So once again, the ability of a solution to conduct electric current depending on the presence of ions. Now resistance. What is resistance? Opposition to electrical current flow, and which is measured in ohms. Resistance depends on distance between electrodes, cross-sectional area, and conductivity. What is specific conductivity? Specific conductivity is the conductivity of a solution between two electrodes of 1 centimeter apart with 1 centimeter square area. What is molar conductivity? Which is molar conductivity per mole of electrolyte in solution. This is the formula of molar conductivity. Here C is molar concentration. This is a note you should know. At infinite dilution, molar conductivity approaches a maximum as ion concentration is minimal. Exactly. Now the second is electrical conduction of tissues of biological fluids. What we are gonna study in this question is how the conduction takes place in our fluids, like biological fluids. What our biological fluids are: blood, plasma, CSF, that is cerebrospinal fluid, urine, even saliva also. So biological fluids contain electrolytes like sodium, potassium, hydrogen carbonate, calcium, which enables conduction primarily through the movement of ions. High conductivity tissues. Tell me what are the high conductivity tissues? These are muscles due to high water and ion content. As I already told you that more the ions, more charge carrier will be there and greater will be the conductivity. So in muscles there are more ion content is there. What is low conductivity? Fat and bones are low conductivity tissues because these are poor in water and ion content. First we will go for the cardiology, that is ECG, electrocardiography. ECG के बारे में आप फिजियो में भी पढ़ोगे, and in second year and third year also in IDP subject you will have IDP subject in which teacher will tell you about ECG. What ECG do is measure the electrical activity through tissues. How? Like I'll tell you the normal ECG, like it is like this. This is P, Q, R, S, and T. Okay. So In echocardiography, it measures the electrical activity through tissues, and if there is any change in the tissue conductivity, it will affect ECG signals. For example, ischemia. Ischemia, what is? The less blood flow, which reduces conductivity. Then in neurology, you will get to know in electroencephalopathy and electromyography. It relies on tissue conductivity for signal transmission. In oncology, tumor tissue often have different electrical properties compared to normal tissue used in cancer detection. Now, factors affecting conductivity. So, इसमें आएगा temperature, pH and pathology. How temperature? If the temperature will increase, the mobility will increase. pH affects the ionization of solutes, and pathology is like dehydration, edema or necrosis. Necrosis is cell death. Necrosis change ions distribution and conductivity. Next we will study about the basics of conductometry. Conductometry, it is an analytical technique measuring the electrical conductivity of a solution to determine ion concentration. Means इसमें क्या होगा कि हम इसमें मेजर करेंगे इलेक्ट्रिकल कंडक्टिविटी एक सॉल्यूशन की, जिसमें हमें पता चलेगा कि उस सॉल्यूशन में आयंस का कंसंट्रेशन कितना है, इधर ज़्यादा है और या फिर कम है. What are its applications? Determination of purity of water, acid-base titration, and analysis of pharmaceutical properties like preparations like drug analysis. Next, conductometric titration. It involves measuring conductivity as a titrant is added. Titrant can be strong acid base or weak acid strong base. Examples क्या क्या हो गए strong acid base के HCl, that is hydrochloric acid, sodium hydroxide and potassium hydroxide. Strong acid base conductivity decreases to equivalence, then increases. What is equivalence? Equivalence is where the acid and base reacted completely. Weak acid and strong base में CH3COOH, that is acetic acid and sodium hydroxide. Initial increase due to salt formation and then rise post equivalence. I'll tell you the graphs also, that is, Okay, now we will see about the emergence of potentials. That is, first we will study about electrode potential, standard electrode potential, and then later we will study about types of potentials. I know you are very much aware of these things, but let's revise. That is redox potential, membrane potential, diffusion potential and electrode potential. First we will start from electrode potential. Arise when metal is immersed in its salt solution due to redox equilibrium. What is redox potential here? Tendency of a species to gain or lose electrons. When loss or gain, like losing or gaining of electron takes place simultaneously, then this process is known as redox reaction, and we will get to know the redox potential. What is standard electrode potential? Measurement of potential of a reaction that occurs at electrode when all the substance involved in the reaction are in standard state. What standard states are? Like pressure will be in 1 atm, like solution will be 1 molar concentration. Then membrane potential. What is membrane potential? It is voltage across biological membrane. Our cell membranes are like semi-permeable. Okay, diffusion is also like arise due to ion movement across membrane. Now let's have some extra edge, that is experimental setup and instrumentation. How we will do the conductometric titration. First of all, equipment will be conductometer and titration apparatus. Conductometer will be for like it is an instrument used to measure electrical conductivity of the solution. Modern conductors are very sensitive, and can record small changes in conductivity. Titration apparatus will consist of burette, magnetic stirrer, and reaction vessels. It is used, but instead of visual indicators, the conductometer continuously monitors the conductivity. Basically, what it is saying that in this process we don't use indicators. So let's draw. Okay. So this is stirrer. This is burette. And these are electrodes. Okay. So this is the setup, which consists of burette, as I said, magnetic stirrer. This is burette, stirrer, and these both are electrodes. Okay, now we will go for the procedures. That is, first of all, we will have to do preparation. Prepare a solution to be titrated in a clean reaction vessel. Then titration. It begins with the analyte solution and record its initial conductivity. Gradually add titrant. As I said, titrant will be either strong acid, strong base, or can say weak acid, strong base also. Record the conductivity after each titrant addition, either manually or automatically with data logging. Then data analysis. Plot conductivity versus titrant volume. Then identify the points where there is a change in the trend or slope of a conductivity data. These points corresponds to the equivalence. Okay, we are done with this. Now, galvanic elements and electrodes. Galvanic cell is also known as voltaic cells. It converts chemical energy into electrical energy via spontaneous redox reaction. I already told you about redox reaction. What is anode? It is at anode, oxidation occurs, that is loss of electron, and cathode, where reduction occurs, gain of electron. Electrodes in medicine. After all, we all are medical students, so we should know what are the use of these things in medicine also. So we use electrodes as reference electrode also, measuring electrodes, and measuring, that is for the pH also, like we use glass electrodes. Then used in ECG, EEG, EMG, that is echocardiography or electrocardiography, sorry, electroencephalography, and electromyography. For the sodium and potassium ions. And the last is potentiometry. What is potentiometry is analytical method to measure the potential of electrochemical cells without drawing current. Clinical applications will be blood gas analysis, like partial pressure of carbon dioxide, partial pressure of oxygen, or pH also. Electrolyte monitoring, that is serum, sodium and potassium, urea and glucose sensors via enzymatic reaction producing hydrogen or hydroxide ion. Here the end of this topic. So thank you so much, and please support me, subscribe my channel, and we are also starting our Telegram channel also, where you will get the upcoming links also. And share this video with your friends also, help them, and our motive is only to help you all. So, and if you want any additional things in this video, like some extra tips or how to study, or any certain queries you are having or you are facing here, so you can DM me also, or you can comment down also. Thank you.